Okay, are we ready to get started? So are we ready now for the last part of chapter 1? Where am I going here? Oh, I'm not going here. I'm going here. Here. You ready? Here it is. This is a little review. In chapter 1, part of the equations was coming up with an equation to find a break-even point, for example. You're told this information, that this product sells for $69 each. Your variable cost is $30 each for each one of these products. This is not on the PowerPoint. This is something I've just made up off the top of my head. Overhead is $80,000. Help me write up an equation. Help me write an equation that will allow you to calculate the break-even point using any variable you want. Jump in.
80,000 equals 69.
Wait, stop. Give me the equation for break-even that ends with equals 0. How's that? Give me that equation.
69x.
69 times is using the x. I'm going to switch it up though. I'm putting a p for whatever reason.
Minus 30 of the same variable.
30 times same variable. However many of these particular p products we're going to make.
Is it plus or minus 8?
You tell me.
No?
What is it?
I think it's minus 8.
Okay, here. What is it?
Negative 80,000.
Minus 80,000. This is, and then keep going, equals
to 0.
To 0. There is one way of writing it. Some people write it where they put parentheses around these two and put a plus there. That's fine also. Next step is you would be solving this, right? Put like terms together. 69 minus 30, what is that? 39. P. Add 80,000 to both sides equals 80,000. What would I do then? Divide each side by 39. P equals. They're showing me that you can take a story and it ends with, set up the equation and step by step calculate the break-even point. That's what it would look like. But I posted this spreadsheet right here. And this will, maybe you want to use this to confirm you're right if you got enough time, or if you end up using this to do it, you got to follow the process of what? Where's your answer here? Whatever's here, you got to tell me you're going to write nothing. My answer is from cell D11. And then you say D8, you put 69. D6, you put a 30. D4, you put 80,000. You write all that out, and then you email me this after we end your quiz. So here's what's going. Fixed cost, 80,000, right there. Variable cost per unit, $30 each. Selling price, $69. And that's it. This is just how many we should make to break even. It's just taking D4 plus D6 times D11. D11 has a 0 in there. So all that you're seeing right now is just that 80,000 there. Watch what happens when I put 1 here. Again, that 80,000 will go to 80,000, $30. Because now it's taking the D11 times D6, that variable cost. Here's our revenue. It's saying however many in D11 times the $69. D8. And then this is total profit loss. If we only sold one item because of that overhead, we're losing $79,961. Now, I'm taking this back to 0. Okay? Follow these steps. And when you get to your computer, some Excels don't have, what's it called? When you go to data, that solver right there is sometimes it's not installed on Excel. So it's a free thing. You just have to install it. You go and do a search for installing solver. Real quick, I just want to give you a hint. You go file, you go down to, I think it's options. Yeah, and then add-ins. Come on. And then you find solver. Just follow the steps step by step after you do the thing. But that's just basically how it's done. Now, to find break even, you follow these steps. Step 1, select the data tab at the top of the ribbon. Step 2, go to what if analysis on the data tool. What if analysis? Oh, I have it confused. Not solver then. Install, this is one that has to be installed on some Excels also. Where we're heading though is the solver one by the end of today, you'll see. Goal seek. Select goal seek under what if analysis. Now it's asking you set cells in your I'm showing you this, so there's a chance this could be on a quiz. It would be how to set up or how to use Excel to find the break-even point. And it may say when this window pops up, if this were on a quiz, you'd see this whole thing except for that dialog box. And you'd see this. And I'd say, what? And this would be blank. I'd say, what goes in set cell? So hopefully your notes it says the set cell. I gotta try to remember. Is, let's see up here, the profit loss cell location goes in the set cell. There's the profit loss, so it would be D17. Instead of D12 right now. D17. So your notes say set cell is wherever the profit loss is being calculated. In this case, D17. To value, we want to get to a break even. So when the profit loss is to 0, that's what we want to know. And then it says by changing what? What you want changed is how many do we have to produce to get to a break even of 0, and that happens to be cell D11. So I got D17, I got 0 and D11, and when I hit OK, Excel is going as fast as it can, trying every number here to figure out what number will get that to 0. Watch. You ready? It's going to go fast. Are you watching? Is everybody watching? All right. Here you go. There it is. 2,051.282 is how many we would have to make to get to a break-even point, or cell, making a cell to break even. Everybody see how that worked? It's posted with those directions. At least get to the point to where you can open up that dialog box and then match it to your notes. What goes in the set cell? Profit and loss location. What goes in value? 0, because we're trying to find a break even. How this is used is, how many do we have to go through to make $100,000 this year? We want, our goal is $100,000 on this particular project. So let's do it again. Cancel. Do it again. What if? What if? Goal C. The set cell is profit loss, which is 17. Our value now is $100,000. How many do we have to sell to get to $100,000 profit? And then how changing, again, production, right there. All I did was turn the 0 to 100,000 because now I'm not trying to figure out what it takes to break even. I'm trying to figure out how many to get to our goal of $100,000 profit. Look at that. 4,615, 16 right in there. That's how many we got to do to reach our goal of $100,000 profit. That's how this is used. Right.
On a problem like this, is the amount of units needed to sell to reach break even with a decimal or without a decimal? Do we have to go to the...
You want to round that as an answer, or you want it to not show these decimals because you changed it up there? I'll take it any way you want me to do it.
But my question is, so it's a 3.8, right? But
what?
Technically we
3.8. What's 3.8?
4,615.38.
Yeah, you don't
but
have
technically we have to sell a full unit, right?
Yeah, so, well, 4,615 will just be so less than $100.
Okay.
And if you do 4,616, it'd be just barely over 100. So either way, again, I'm flexible. I am not sitting there putting any handcuffs on you guys saying you have to report it this way with this many decimals. I want you to do it any way you feel is an appropriate way to report this. However many decimals you want, or no decimals, as long as your rounding is correct. Everybody understand that? One person may say 4,616. One person may say 4,615. Which one's correct? The 15 or the 16 one?
Well, the 15 would be the correct round.
Because the next digit's a 3. So as long as you're rounding correctly, I don't care how far you go. All right? All right. Any other questions? Can I go? Keep going? We're good with break even? Next. Are you ready? Hang on. Let me get this out. No. Next, we're going to, right here. All right. This is a little bit of review. Here's some good news. On the first quiz, if there's a problem where I'm asking you to formulate the linear programming model, you remember from last week I said the linear programming model includes 3 things: defining the variables, the objective function, and the constraints, right? For this first quiz, I'm going to define the variables for you. Now here's my hint. Do not use any other variables than the ones being given to you, because the ones being given to you are the only variables for that story, and you're thinking about it way too much if you think there's additional variables than what's given to you. So instead, go with the mind frame for this first quiz. Okay, we're being given the variables. Now use those exact variables in your objective function and your constraints, however they should be used, but don't start overthinking. Go, wait, there should be this variable and that variable. Go with whatever variables are given to you, because the ones I've given to you are the only variables that are part of that problem. In this case, there's x and y, two variables in this one. Now this is so easy. Do not let your guard down if you think this is what the quiz is usually like. This is that easy. This is too easy. But this is an example. Just refresh your memory. Candy manufactured by sugar from two suppliers. One's called sugar supplier 1, one's called sugar supplier 2. The candy manufacturer needs at least 55,000 units. Think about it as you're reading this. Is that a limitation? Is that a limitation? The candy manufacturer needs at least 55,000 units. Matter of fact, I'm jumping in. 55,000. The candy manufacturer needs at least 55,000 units. Less than equal, greater than equal, or equal? Greater than equal, because it says at least 55,000 units. You jump all over the right side of these as you're reading it, it just makes it so much easier. The way, at least for me, is how I used to do it. Supplier 1 can supply up to 36,000 units. That's a limitation. Let me read it again. The supplier 1 can only supply up to 36,000 units. You know what I'm asking? What's right here? Less than equal, because it says up to. No more than that. Up to, less than equal, 36,000 is all we can order from supplier 1. Supplier 2 says it can only supply up to 26,000 units. There's another limitation. What goes here? What goes here? Less than equal. Very good, because only that supplier can only supply up to 26,000 units. That's it. The price per unit of supplier 1 is $5 a unit. We order from supplier 1, and supplier 2 is $4.50. Now this is so easy that right now I can hear some of you going, well, we're going to order as much as we can from supplier 2. Why would we order from supplier 1? But there's only so much we can get from supplier 2, and we need 55,000. So right now you're saying to yourself, I'll order as much as possible from supplier 2 to save 50 cents, and then whatever additional amount I'll need, I'll pay the extra 50 cents for it. That is the optimal solution. The logic you're thinking that I just stated is exactly how this is done. But I want you to realize this is such a micro problem that's only about teaching you how these are turned into constraints and objective function. In real life, I've never had a problem that only has 3 constraints and 2 variables. It's more like 10 variables, 50 to 100 constraints. And there's no possibility of you solving it in your head, period. So I just want to make sure you realize, oh, this is so easy. I can do this in my head. Why do we need linear programming? This is all about just showing you the process. You'll never see a real problem in real life this small. Okay? So I want you to get that, relaxed. Even though this is so easy you can do in your head, in real life, you will never be able to do it in your head. So now we got that far. Let's keep reading. We got the prices, $5 and $4.50, depending on which supplier. Write an objective function, write constraints to solve this question. Now, when we get to quiz 2, when you see this part to solve, this is where you say to yourself, okay, the variables have to be whatever questions need answered, whatever it is we're trying to solve. So this is how you would come up with your variables. In this case, I'm giving them to you, but look at how the variables match this statement right here. To solve how much sugar should be purchased from each supplier. That's the unknown. That's what this is all about. X equals how much from number of units from supplier 1. How much? Y equals the number of units we're going to order from supplier 2. Look at how that matches this perfect. Write objective function constraints to solve how much sugar we should purchase from each supplier. There's 2 suppliers. There's how much we should order from each one. 2 variables. The most difficult part I see from most of the students when we get to the next quiz, they're coming up with these variables. So I'm trying to simplify it, trying to make it as simple as possible so you don't struggle on coming up with your own variables. That's kind of the kind of thing you're going to see, and you're going to say, okay, that's what needs to be answered, so that's what my variables are. And then you relate all of these to the variables. And not only how much to order from each supplier, but to keep our cost as low as possible. That second sentence I just read there, what is the story telling you? It's telling you what part of the story, what part of the equation is that sentence to keep costs as low as possible. Is it part of your variables? Is it part of your constraints? Is it part of your objective function? What is that sentence? Objective function. Max or min? Min. Because it says to keep costs as low as possible. That's the objective. That's how you find the objective from it. What's the objective here? Yes, we do want to know how much to order from each one, but the goal is that the answer of how much to order keeps our costs as low as possible. You never have an equal sign, a less than equal, or a greater than equal in an objective function. Don't make that mistake. It's just the word max or min. I accidentally put max, but it's min, or minimize if you want to write it out. Our variables are, tell me my variables. We don't have variables? Oh, X and Y. Okay, how much does it cost to order from supplier 1? How much for each unit? $5.50. $5.50 times however, what happens?
Just five.
Thank you. Let me write it again. $5 times however many units we're ordering from supplier 1 represents the total amount we'll have to pay them for that sugar. Plus, how much is the other supplier? $4.50 times Y, however many units we order from the second supplier times $4.50 represents how much we'll have to pay in a bill from them, right? And together, that is how much our total bill is for these 55,000 units we're about to order, or at least 55,000 units. And it's a min because these represent costs. Objective function is done. Let's go to the constraints. We identified the limitation, but now on the right-hand side, we know if it's equal, less than equal, or greater than equal by the words that were in the story. But now on the left-hand side, there's either one or two or both or whatever variables involved. But the variables represent how many units. And so if the right-hand side is something different than the number of units, you need to put something with the variables so that they're talking about the same thing. Now in this case, greater than 50,000, this is number of units. If this said spend at least $55,000, we can't use X and Y because X and Y are not how much money we're spending, it's how many we're ordering. So we would have to put the money with it, like we did down here. But this 55,000 isn't dollars. This is the units we need at least to fulfill the requirements for this production that's coming. So the left-hand side has to be the number of units we're ordering. This is from both suppliers, so the left-hand side is probably what? The number of units we order from the first supplier plus the number of units we order from the second supplier, because that's what the variables represent. When added together, have to be at least 55,000 units, because we need that much for this next production cycle. So it says manufacturer needs at least 55,000 units. Okay, help me with the next one now. Whatever we order from supplier 1, we can't order more than 36,000 units, so what would be on the left side here? And nothing else? Because X represents the amount of units we're ordering from supplier 1, and this right-hand side is only about supplier 1, and that's the number of units, so we have units and units. However many we order from supplier 1 has to be less than or equal to 36,000. And supplier 1's more expensive, so the odds are we're not going to order all 36,000 unless we have to. Supplier 2, 26,000. What's on the left side of this constraint? Y. However many we order from the second supplier, which is what Y represents, has to be less than or equal to 26,000. You've now taken a story, you wrote the objective function, you wrote the constraints, and you've got to get to the point to where you can identify what the variables are and define them. For this first quiz, I'm giving you the variables, what they are and what their definition are. Because that's the hardest part of these for a lot of people, and so that's the part you got to get to. We good? We got this? Is this posted? I can't remember. Yes? If you want to do a maximum, then this might be, and every unit of sugar we buy from this supplier, we end up making $5 profit on, and every unit of sugar we buy from this supplier, we're making $4.50 profit, and then the sentence will say, if the company wants to make as much profit as possible, max 5x plus 450. The sentence will be all about profit probably, or something positive. When you read the objective function, you got to look at it from the standpoint you're the manager of this, and you're the one that's getting that 55,000 units. And so when it talks about profit to you, that would be something you'd want to max. And when it talks about cost, from the manager, you're the one running this process, in your point of view, if these are costs, that's something you want to minimize.
That isn't in Blackboard.
It's not? Okay. I'm going to try to remember to post this site, and I think I have one with the answers, so I'll post it with the answers, or do you even need the answers? You guys wrote it all down, right? Is that right? So you don't even need the answers? Probably? I don't know if I have one with the answers, but this one will go off, or one with the answers if I find it, okay? All right, let's go to the next step. Boom. This is not about how to use Excel to solve it. We're not there yet. Chapter 2 and really Chapter 3, we're going to be solving these, putting them in Excel, putting them into software, and solving them, and analyzing the results. This chapter for today, and to prepare for the quiz, if this is on the quiz maybe, who knows, to prepare, it's all about how do you set up the Excel spreadsheet, and where do you put the numbers from the constraints in the objective function. All right? So I posted one that's all set up with zeros as kind of a template for you to use. And when we start getting into harder problems, you're going to have 3 variables, 4 variables, 5 variables. If you want to use this all semester, just go to insert column. It'll all scoot over and add another variable. Or if it's 4 variables, insert another column, add another variable. So the reason this may help you all semester as a template is because I did the formulas already for the most important cells. Now let me explain this. Everybody with me? At the top of this, it's all about entering the data that you came up with when you wrote the constraints in the objective function. Right? X and Y, constraint 1. Look at constraint 1. What number is with the X? What was the right hand side? 55,000?
Yeah.
There's that. What number is with the X on that first constraint? 1. What is it? It's just an X? Okay, 1. Thank you. What number is with the Y? 1. Good. What's the right hand side of the second constraint? 36,000. Okay, let's go over here. What number is with the X on the second constraint? 1. What number is with the Y? 0. Yeah, it's not there. Good. Okay, the third one, what's the right hand side? 20 what? 6,000. What number is with the X in that one? 0. Okay, what number is with the Y? 1. This is the numbers within the objective function. What in the objective function is with the X? 5. What's with the Y? 450. You're done with the inputs. The whole top of the spreadsheet is for where you input it. Now let me show you the formula that you need to understand how it would be written and how it's used, I guess. But ready? The first one, well, let me talk about these. These 2 cells, you always just start with a 0 there because this is where you're going to have to Excel place the optimal solution. They're going to tell us exactly how many we should order from the first supplier, 1, and how many units we should order from the second supplier right there. This is going to be the optimal values for each of the variables right there. And if there's another letter here, that would be the optimal solution for that one. If there's another one here, that'd be 5, 6, 7, 8 variables. It would be the optimal solution there. This is the objective function value. And what's happening here is where it says, in this case it says max, but ours is going to be a min. If you were to take and put the optimal solution for X here, and the optimal solution for Y, which means maybe we're ordering, hang on, which one's the cheapest one, the Y? This will probably end up being 26,000, but we need 55, so this will be like another 29,000. When you take $5 times the 29,000, or whatever the optimal solution is, you take 450 times 26,000, or whatever the optimal solution is, and you add them together, you just found the objective function value. It's the value the objective function would be when the optimal solution is inserted. That is right here. Now let me show you something, right? To get that value, we took the number with the X and multiplied it times the optimal solution for X. You got to write that using cell location. I'm not going to click here yet because I want you to see this before I click on it. I'm just doing that first one. The number with the X, so cell location F10, times the optimal value for X, so times, what is that, F14. And then plus That number is the number with the y in the objective function times the optimal solution for y. So your formula would be plus G10 times G14. That's how you come up with those formulas. Whatever you're doing here, there. This spreadsheet's posted with the formula there to use for you as a template. You go, okay, I got to come up with that objective function formula. Hopefully you'll look at this one and go, oh, I see. It's this number in the objective function times the optimal. This number times the optimal, and they're added together. Because you look at the written objective function and they're being added. These other formulas down here, these are the left-hand side of constraints. And what they represent is each one of these, but if you were to put the optimal solution in for that variable, and you put the optimal solution in for that variable, and you multiply them times the corresponding numbers that are with them. In this particular case, you guys see this? There's a 1 there and a 1 there. So it'd be whatever the optimal solution times 1, whatever the optimal solution times 1, added together. So look here. Ready? F7, 1, times F14, the optimal solution times the number that's with that variable in that constraint, plus G7 times G14. That's what's up there, which is exactly what we would do if we insert the optimal solution here. This one, same thing. You got to pretend there's a y there even. Might as well put the full formula in. So it would be the cell locations where you enter the numbers that go with the variables times the optimal solution. So this should be, what is that? F8 times F14. G8 times G14. Sure enough, F8, F14, G8, G14. See what's going on? The same way it's written, you're using the cell locations as if it were written to do the math. This cell and all these left-hand sides, and you're getting to where you're going to have 5 constraints, 6 constraints, 7 constraints, 10 constraints, 12 constraints. All these left-hand sides have formulas. These are all equations that represent exactly what would be done if you were calculating the left-hand sides here once you know the optimal solution. So help me with this one before I show you. What's the first cell location times what cell location? I'm on the third constraint left-hand side. Give me a cell location. F9 times F14 plus G9 times G14. That is exactly what's in that cell right there. I can tell a few of you are going, wait a minute, I'm not sure I got a handle on this. All right? Let's solve it. You don't have to solve it. You want to see how you solve it, though? Just to see how it's done? Do you want to know the answer? You guys already know how many of them, right? It should come up with 26,000 for Y, and what did you say the other one was? 29,000 for X if it's done right? Go ask your question.
Yeah. What's the difference between this and the linear program model?
This is linear program.
Okay, this would be.
Yeah, this is if we're using Excel to solve it. You're about to learn how to use a software to solve it too.
Okay.
But we're not solving it. It's just, this is all about how you would set it up in Excel. This is the point of today's lecture. How would you set this up? If this were a picture on your quiz, and I said to you, well, what is in that cell right there? Can you tell me the cell locations used, what's in that cell right there? Equals. Help me out. F9 times F14 plus, right? You see where I'm going with this? You can have this open while you're taking the quiz. This is posted. It's part of the materials. You can look at it while you're taking the quiz. You understand? Right? Well, I don't know. I got some vital news that's very confusing. Very confusing. Go ahead.
So are you saying that you're going to put this on the quiz and then ask us how to solve it?
No, you're never going to be asked how to solve it on the first quiz. I don't expect anybody to solve these yet. That's coming up.
Okay.
You just need to be able to write constraints, write objective function, or let's say it's set up like this. This is a whole separate problem. You need to tell me what would you insert if you had to come up with that equation. What would it be? Looking at all this, what would that be? What would that be? What would that? These 4 equations are the hardest part of this. Now, what I'm about to show you. Huh? The next quiz, what I'm about to show, no, that's this quiz. What's this, what's this, what's this? It's on this quiz. The next quiz is solving this. I'm about to show you to solve it, but it won't be on the quiz. But let's see the answer is what we expected. You ready? This is the one where you gotta use that solver.
Yes.
Okay, solver, don't memorize this, you don't need notes, we're gonna go through it again. Set objective is always wherever, and by the way, this is supposed to be minimized, not max. I can't change it now if this is open. F16, this is a minimize, right? Minimize, changing variables are being where do you want the optimal solution to be placed? Right there in these two cells. F14, G14, go down here, we're gonna add constraints. We have 3 constraints. I'm going fast because this is not part of your quiz. We're just solving it. The left side of the first constraint is placed right there in F20. It's a less than equal or greater than equal? Greater than equal. We're gonna switch this to greater than equal, and the right side is right here, 55,000. Let's add another constraint. The left side right here at F21, it's at less than equal though, right? Less than equal 36,000, is that correct? 36,000 right there. Let's go one more constraint. The left side is there. It is a less than equal to 26,000, is that correct? Anybody with me? Okay, I did all 3 of them. I hit okay. All 3 constraints are right there. You got to make sure and check this box. You got to make sure and switch this to simplex method. We're using the simplex linear programming method. Now it's going to go fast. You ready? And if this is done right, this should be whatever and whatever. 29 and 26?
How does it know about the 5 and the 4.5?
Because we have it right there, 5 and 4.5.
Yeah, when did we put that in?
When we were inserting all these other numbers, 1, 1, 1, 0, 0, 1, 5.4.5.
Oh, okay.
You ready? Here we go. It's solved, then you click on OK. We should be ordering 29,000 from the first supplier, 26,000 from the second supplier. If you insert those numbers into the objective function, this will be a min. This will be $262,000. This is not on your quiz, but I want to see if anybody can tell me what is $262,000. What is that explained to us? $262,000 is what? Yeah.
Is that how much it costed us?
It's like the minimum cost?
The absolute lowest cost you can get your problem set up. You may be able to order a different amount from supplier 1 and 2 to match that cost, but there is no other lower cost situation to fulfill that order of 55,000 units of sugar. So let me make sure I say that again. The goal of the company wanted to make sure to keep their costs as low as possible. They want to know how many we should order. That is your answer. You cannot get it below $262,000. Whatever way you decide to order, that's the lowest you can get it. So you might as well go with the suggested optimal solution and order 29,000 and 26,000 because that's the lowest you can get the cost. Everybody see that? That's what that's answering. What's happening here? The left side of this constraint and the right side of the constraint are the same. So that means we are ordering exactly 55,000 units of sugar. 29,000 and 36,000 are not the same. That means we either have some slack or surplus, factor 3, 2, 3, something like that. And this one, 2626, we're ordering exactly the amount of sugar that's available from that supplier. And here we're not ordering it all. We have either some slack or surplus, which you're going to learn later. And now, my question for you is, if you have nothing but zeros in here, like it originally looked like, and I take that back. Yeah, zeros. And I said, okay, take this linear programming problem and set it up in Excel. Let me get my zeros in. Could you know how to set it up in here? I just handed you a linear program. I gave you the constraints. I gave you the objective function. And the variables match X and Y. You may change these to whatever it is. Could you take that and enter all the data here just like you see it there? That's where you need to be today, and to understand how to write these equations right. But it's a matter of you knowing how to enter this data just the way the constraints and objective functions work.
Are we supposed to know how to do the formulas for like
No.
the cell references and all that? Or?
For what?
Like each one of those has like a formula in it. Are we supposed to set that up? Or
Just this equation, these equations, you're supposed to know how these are set up, yes. Is that what you're talking about?
I meant like in the cells, like right there. It says F10.
Yeah,
We have to type in
that
all
equation, that equation, that equation. These are the 4 that have equations like that. You do need to know these.
So we have to know like what to type in there to make
Yeah,
it work.
yeah, but you have this open while you're taking the quiz. Okay? This will guide you. It won't be those exact cells. It won't be, maybe it won't be F and G or 10 and 14, but use the logic and then apply it to what you're seeing. Get it? Everybody understand what I'm saying? Okay. We have one more thing to learn, and that is this. It's not about how to solve it with this either. That's a later chapter. I want to make sure you know how to set it up using the software. Now here's the deal. Many companies use these softwares, and there's like a ton of different ones. Every one of them are really doing the exact same thing, and the outputs are the exact same information, but they all set it up differently. You know, if you're used to one software, you're going to find the same information from the output of another software, but different locations, presented in different ways. You just got to look around. Oh, there's this, there's the objective function value, there's the optimal solution. So they're all different. My goal here is to get you so familiar with this one and what the output has, that when I show you a different output from a different software, that you can identify all the things on that one because they're the same, just being presented different ways from this software, okay? That's the goal here. We're doing linear programming, which is module 1. We're doing a new one. How many decision variables are there in that problem on the board over there? 2, X and Y. How many constraints are there? 3 constraints. Is this a max or a min? Min. Here we go. And we'll call this one X, and let's call this one X. And let's call this one Y, just like we have it there. Notice it changes in both boxes, it changes for you. Once you change one, change the other. Okay, the first top one is the objective function. It just wants to know what numbers are with each variable in the objective function. So with X in the objective function, what number goes with X? 5. What number goes with Y? Very good. Now let's get down here. I like to start with the right-hand side. The first constraint is a 50,000. Oh, thank you. And then it's a less than equal, greater than equal. Greater than equal. You don't have to put the equal. You just put the greater than on the software. The software assumes equal with it on every one of these. So just put the greater than. What numbers with the X in that particular constraint? 1. What numbers with the Y? 1. The next one is a 36,000. Less than equal, greater than equal, or equal? Less than, you just put the less than. It assumes the equal. What numbers with the X in the second one? 1. What numbers with the Y? 0. Third one, 29,000?
26.
Thank you. Also less than? And then the number with the X?
0.
And the number with the Y? That's it. I need to know you can do this, that you can enter this in, be ready to solve on the software. If I gave you a picture of this and I said, what would you enter under constraints, constraint 1 under the X? I need to know that you would know what to put there when you're looking at constraints and an objective function like that. If you're looking at that, can you determine what would be entered? If I ask right here, what would be entered? Can you determine it? And you go, oh, that's 26,000. So that would be a 1. I need you to be able to do that. That's how far we need to be today. But I know you want to see it solved. You ready? Okay, let's do it. I'm going solution, solve. Our optimal solution on this software is right up here. Supplier 1, we should buy 29,000 units. Supplier 2, we should buy 26,000 units. There's the objective function value up there. Which, by the way, right here, the number 5 is with the X. 5 times 29,000. 450 is with the Y. 450 times 26,000 added together, 262,000. Just like the Excel, right? The objective function value is the same. The rest of this you're learning in chapter 3. Chapter 3. You go back here. Can you do this? You feel good? Feel okay? No problem? I think we're done today.